This is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about solid mechanics and material subject. So in this subject, in previous session, so already we have some discussed about the question bank. So the shear force and bending moment diagrams related questions we will discuss in today's session. How to attempt the question in examination I will explain. So the shear force and bending moment diagrams, the topic. So at the end of the course, the student should be able to illustrate the shear force and bending moment distribution in beams, and for analyzing the structural behavior under various loads. So at the end of the course, students should be able to illustrate the shear force and bending moment distribution in beams for analyzing the structural behavior under various loads. So already we have discussed about shear force and bending moment, and how to draw the shear force and bending moment diagrams, and the theory part and problems also we have covered. But in this session, so particularly one or two questions we will see. So how to answer for the given question. See, the simply supported beam with a point load. So here question taken related to the simply supported beam. So already we know various beams are there: cantilever beam and simply supported beam, and then overhanging beam. But in this question bank session, I will explain the simply supported beam with a point loads and UDLs problems, how to solve. See here, question number 1. This question taken from the question bank. A simply supported beam of length 6 meter carries point load of 3 kilonewtons and 6 kilonewtons at a distance of 2 meters and 4 meters from the left hand. Here draw the shear force and bending moment diagrams for the beam. So the given type of beam is simply supported beam. Clear? So the length is 6 meter, carries a point load of 3 kilonewtons, 6 kilonewtons, a distance also given from the left hand side only. You know simply supported diagram, how to draw the load diagram and shear force and bending moment. But here he is asked here, draw the shear force and bending moment diagrams for the given beam. So first of all, you should calculate the shear forces and then bending moment values, and then draw the diagrams. See here, the given diagram is the AB is a beam. Supported ends are A and B. The A and B is RA and RB, reaction forces. So the point loads are 3 kilonewtons and 6 kilonewtons at C and D. So the overall length is 6 meters. So RA plus RB is 9 kilonewtons. So the total upward forces and the sum of the upward forces and vertical forces. The sum of upward forces RA plus RB is equal to downward force 3 plus 6, 9 kilonewtons. And the distance is also given, the point load acting distance 2 meters from the left hand, and 4 meters from the left hand. Again, one more point load is acting at point C. So first you calculate RA and RB, and then shear forces, and then bending moment. So taking moments about the force about A. So RA into 0. So there is no distance behind the left side portion, plus 3 kilonewton into 2. plus 6 into distance. What is the distance? The 6 load acting with 4 meters distance. So 6 into 4 minus 6 into RB, that is equal to 0. So taking moments of the force about A is RA into 0 plus 3 into 2 plus 6 into 4 minus 6 into RB is equal to 0. So total we got RB is equal to 5 kilonewtons and RA is 9 minus 5, that is 4 kilonewtons. So RA and RB we have calculated. So now calculate at each and every point the shear force. So RB we got 5 kilonewton and RA 4 kilonewtons. So the shear force at B point, the right side portion. So the given diagram is like this. RA and RB, the total is 6 meters, C and D. So this is 2 meters, and 3 kilonewton and 6 kilonewton. So now calculate shear force at B point, right side is 0. And B left is minus 5 kilonewtons. RB is equal to 5 and RA is equal to 4. 4 kilonewton and 5 kilonewton. So the left side is minus 5. So the force is acting upward. So that's why taken here negative sign. And immediately C right is up to C, this force, the B left minus 5 kilonewtons remains constant. At C right side. At C left side, immediately acting the vertical load, that is 6 kilonewton. 6 kilonewton downward force, and here upward force is minus 5 kilonewton. Six kilonewton and minus 5 kilonewton. So 6 minus 5, 1 kilonewton. At D point, 2 meters at D. At D, right is 1 kilonewton and left is again at C point. At D point, here 3 kilonewton is acting at D plus 1 kilonewton. D right is 6 minus 5, that is downward. So 3 plus 1 kilonewton. So total 4 kilonewtons acting at left side of the D. So similarly calculate bending moment. So the bending moment at B point 0. Again draw the diagram. A, B, C, D. Two meters and 2 meters, and this one is 6 meters. So what is the bending moment at B? 0. The bending moment at C, 3 kilonewton and 6 kilonewton, 5 and 4, RA and RB. So 5 multiply with these 2 distance, 2 meters distance. So total 10 kilonewton meter. At D, this 5 into 5 multiply with 4 minus the 6 kilonewtons multiply with 2. We will get 8 kilonewton meter. At A point, the bending moment at A, 5 into 6 minus 6 into 4 minus 3 into 2, total 0. So, it means at their support ends, there is no bending moment. The bending moment B is 0 and A is 0. So, the remaining C and D, you should calculate at C and D bending moment. Now, you got shear force and bending moment values. Now, draw the shear force and bending moment diagram. This is load diagram. The given loads RA and RB we have calculated. Now, draw the diagram. At B, what is the value? Shear force value. So, at B, right is 0, the left is minus 5 kilonewton. So, that's a negative sign. So, downward, this is the baseline. So, draw the one baseline and then above positive values and below negative values are shown here. So, the 5 kilonewtons up to D, again 6 minus 5, 1 kilonewton positive, and here this remains constant up to C, and again here 3 added, and then remains constant up to A. So, obtained shear force diagram. Similarly, bending moment diagram. So, at C, at B and A, 0 bending moment. So, here too, there is no bending moment but B, and here it follows inclined line, straight line, and then here 10 kilonewton meter acting at D. Again, up to C here shown 8 kilonewton meter and then 0. The positive values, all are positive. So, bending moment is positive and shear force plus positive plus negative. So, like this, you should draw the shear force and bending moment diagrams for the given question. So, in the question given for the load values, so draw the shear force and bending moment. So, for this, required shear force values and bending moment values. Next, question number 2. So, this is related to simply supported beam with UDL, uniformly distributed load. So, question number 2, what he has asked is, read the given question. Draw the shear force and bending moment diagrams for the simply supported beam of length 9 meter and carrying a uniformly distributed load of 10 kilonewton per meter. So, your given load is UDL, that is 10 kilonewton per meter, for a distance of 6 meters from the left end. Also calculate the maximum bending moment on the section. First he has asked, so draw the shear force and bending moment diagrams, and then also he has asked maximum bending moment, where it will occur. So, in this, the type of load is UDL. First you convert into point load, and then all shear force calculation and bending moment values remain same as point load. Simply supported beam with point load conditions. See, the given load diagram is RA and RB you should calculate. RA plus RB, 60 kilonewtons. Why? Because the 10 kilonewton meter UDL multiply with 6 W into L. So total 60 kilonewton meter converted into point load. So now the taking moments about the forces about A, RA into 0. This 10 into 6, that is 60, multiply with the half of the distance W into L by 2. So L by 2, for UDL case, you should take half of the distance, the 6 by 2. So they converted into point load. So that's why you should take half of the distance and minus 9 meter multiply with RB, that is equal to 0. Now calculate. RB is equal to 20 kilonewton. RA. So RA plus RB is 60. So that RB 20 and RA is 40. Now calculate the shear force and bending moment values. So here draw the diagram RA and RB. The UDL is given A, B, C up to C. 10 kilonewton per meter. 6 meters. 6 meters and 9 meters total. RA is 40, RB is 20. 20 kilonewtons and RA is 40. So now calculate shear force at bending B at right side is 0 and left side support force acting, so that minus 20 kilonewton and right side this minus 20, the C right side at C point, right side and left side. Similarly B right side and left side. A right and left. So calculate values. The right side is minus 20, it remains constant, and left side is minus 20. There is no load acting here, but A there is a UDL. So that the minus 20 plus 10 into 6. So that is a UDL case, UDL load, 40 kilonewtons. Similarly, A left is this 40 minus this UDL obtained A right, that value 0. So at there B right is 0 and A left is 0 shear force. Now calculate the bending moment. See, the bending moment value at B is 0, and A is 0. At their support ends, you will get 0. The remaining point is C. So what is the bending moment at C point? At C point, 20 multiply with 3. So 20 kilonewton multiply with these 3 meters. So we will get 60 kilonewton meter. Now draw the bending moment diagram. So we are drawn according to the obtained values of shear force. So baseline drawn and above values are positive and below negative values are drawn below. Here at D to C taken X and the total A to C is 6, so that's why 6 minus X taken here. So this is for maximum bending moment where it will occur. He has asked in question. So that purpose you need to calculate a x value and then you will get the final maximum bending moment. So it follows the bending moment diagram parabolic. The positive values only 0b, 0, a 0. But maximum will occur at this point. Say at x point. So I will show you how to calculate. So compare the similar triangles x by 20. So this diagram and this one. A. So we can put B, D and E. And again, one more diagram D, C or another notation F. So compare these two diagrams, two similar triangles. So AD 6 minus X and AE 40 and this one is 20 and X. Okay. So now compare two similar triangles. 40x is equal to 120 minus 20x and 60x is equal to 120. So therefore, you will get x value. So now the bending moment at D, now calculate 20 multiply with 5 minus 10 into that UDL load into 2 into 2 by 2. So half of the distance W into L into L by 2. So we will get 80 kilonewton meter. So here solution once again here drawn. Clear? So the maximum bending moment occur at a D point at a D is 80 kilonewton meter. So here shown diagram at C 60 and what is the bending moment at this point? Normally without sectioning with x distance we can't calculate. So that we have taken at this point x and then distance you have taken and then compare the triangles. So finally we got the maximum bending moment. This is the calculation procedure for the maximum bending moment. So he has asked to calculate the maximum bending moment on the section. So we have completed shear force and bending moment diagrams and then also we have calculated the maximum bending moment. Clear? So and also drawn the bending moment diagrams and the shear force diagrams. See, so for this PPT, I have taken references as Ramamurtho, Strength of Materials, and publishers are Dhanapati Rai Publishing Company, and R.K. Bansal, Textbook of Strength of Materials, and publishers are Lakshmi Publications and R.S. Kurmi and Gupta, Strength of Material title. So these are the references I have taken for this question bank PPT. So refer any textbook and then for further more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.